Hello, Accelerated Math 7-8 students. We are beginning our sixth video, and the sixth video that we are going to be working on today is called Rational Numbers and Division. Okay, and we will find that on page 18 in my comp book. So please make sure you're getting your table of contents written down while I turn to page 18. And here is page 18. So here we go. Rational numbers and division, our goal. Today we are going to practice converting decimals and fractions by incorporating long division. The question that I want you to be thinking about this morning or today is, what kind of equivalent fraction makes converting a fraction into a decimal the easiest? What kind of equivalent fraction makes converting a fraction into a decimal the easiest? Okay. Hopefully by the time we get working through this material, you'll understand what that question is asking. The first thing that you need to know is that place value is key. Okay, so whenever you're given any number and you're trying to convert it from a decimal to a fraction or a fraction to a decimal, knowing your place value and your place value chart is very, very helpful. So one of the things that we can learn by knowing our place value chart is, what is the value of this number? Basically, how you figure that out is you read it mathematically. So we would say this number is 1 and 33 thousandths. Okay? And the reason we know that this is thousandths is because this is tenths, hundredths, thousandths. And the last digit is the name of the decimal. So 1 and 33 thousandths. Okay? If you don't know, make a place value chart. So that's what I did right here to help us. So here's my place value chart. I always start with the decimal and then I work left and then I work right. This is the ones place. This is the tens place. This is the tenths place. This is the hundredths place. This is the thousandths place. And this is the 10,000ths place. And so then you line up your decimal in your place value chart and you see 1 decimal point 0, 0, or 033. Seeing that the last digit sits in the thousandths place teaches me how to read it. So again, 1 and 33 thousandths would be this number. Okay? So the next thing that I want you to be thinking about is, how do you take this decimal that we see right here and write it as a mixed number? Okay? And again, I would highly recommend reading it out loud. 1 and 33 thousandths. So basically, you would just write exactly what you're saying. So I need everybody to do that right now. How do you write it as a mixed number? You're going to write it right there. Okay, this is going to be one of the questions that we check in the morning. How do you write it as a fraction? This mixed number and this fraction are not the same thing. So I do not want to see another mixed number down here. You need to take this decimal and write it as a fraction. That's your next thing that I want to see if you can do. Okay, it is kind of interesting, so we'll have to work that one out. What is a tool you can use to convert a decimal into a fraction? Anybody? Sitting right up here. Okay, make sure you write the answer to that one on there as well. All right, so now we're going to keep going in our notes, and we're going to talk about converting fractions into decimals. I am going to remind you yet again, when you start a new page in your notes, you need to have the title up at the top, and this says, Converting Fractions into Decimals. This can be a tad more difficult. There are a few steps to follow that makes the process easier. So step number 1, okay? The first thing that I want you to do is identify the denominator. The second thing that I want you to do is determine if it has a multiple of a base 10. Okay, we'll talk about that in a minute. Step 3, create an equivalent fraction with a base 10 denominator. Step 4, read it out loud. And then step 5, write what you say. Okay, now I don't know if you guys are understanding step 2 or step 3 that well, so when we practice one in just a minute, I'm going to show you exactly what that means. So the first thing it said is identify the denominator. So here is our example that I want you to look at for just a minute. Okay, and the example that we're going to be working with is a pretty simple fraction. It's just 3/4. And I'm pretty sure that you all know what that is already as a decimal, but that's not the point. The point is to teach you the steps so that when you're having to work on a fraction that is not a very widely known fraction turned into a decimal, that you'll be able to do it. So the first thing it says to do is identify the denominator. So the denominator in this problem is 4, okay? Once you figure out what the denominator is, then you do step 2, and it says determine if it has a multiple of a base 10. So we have a multiple that gets us to have a 10, but this is not base 10 because base 10 is 10, 100, 1,000, 10,000, 100,000, and so on. But I know that if I can get it to having a multiple that can be converted to a base 10, it would be very easy to do so. So I know that I can take 4 and multiply it by 5, and it gives me 20. So the first thing that I'm going to do is I'm going to use what we've been using forever, is the multiplicative property. And let me enlarge it a little bit if I can, so you can see what we're doing. Okay. And so we have 3/4 times 5, 5 giving me the denominator of 20. And so what I do to one side, I have to do to the other. And so 3 times 5 is 15. So now my new equivalent fraction is 15/20. And then after I have 15/20, I then am looking for a base 10. 100 is considered a base 10 because it is a multiple of 10. So that's what we're talking about with base 10s, is if they are multiples of 10. So then you ask yourself, how do you get from 20 to 100? Well, I can get from 20 to 100 by multiplying by 5 as well. So 20 times 5 is 100. What you do to one side, you have to do to the other. 15 times 5 is 75. So now I have a fraction that has a denominator of base 10. And once I have a fraction that has a denominator of base 10, the last thing that we have to do is read it out loud. So now I have 75 hundredths, and then you write what you say in decimal form. So you have 0 and 75 hundredths. That is how you convert 3/4 into a decimal using these steps. Now, some of you are saying, Mrs. Nelson, do I have to go to all that trouble if I know it already as a decimal? The answer is no, you don't. But there is going to be a time when you're asked to convert fractions that you're not familiar with into decimals, and this is a way of doing it that will be helpful for that. Okay? So that's the reason I'm going over it. Reading it 75 hundredths, write what you say, and there you have it. Okay? So the next thing that I would like you to do is I have given you 2 practice problems that I want you to try, and let me move them up so you can see them. So the 2 practice problems that I want you to try, running through these 5 steps up here, I would like you to try the fraction 4/5, and I would like you to try the fraction 3/40. So your job is to run it through these steps up here and then figure out how you can convert 4/5 into a decimal and 3/40 into a decimal. That's what I would like you to do. All right? So then the next thing that we need to briefly discuss is types of decimals, because there are actually 2 types of decimals that we're going to be working with on these standards, and they are the type of decimal can be determined if you can find a base 10 denominator. They are terminating or repeating. Okay? So the 2 types that we're talking about right here are terminating or repeating. The decimal that comes from a fraction that has a base 10 denominator usually is a terminating decimal because it stops, because it has a base 10 in the denominator, and that means eventually it will stop when you find the correct factors that build it. But we're going to go over that a little bit in just a minute. A repeating decimal is one that as you're dividing, you're just going to repeat a certain number over and over again. So I'm going to turn the page, and we're going to do a little bit of practice with these 2 types of decimals. So again, write your title at the top of your page, please. And now we're going to write down the definitions for each type. So a terminating decimal is a decimal that stops. Examples of terminating decimals are 0 and 25 hundredths, 0 and 125 thousandths, 0 and 875 thousandths. All of those decimals stop when you entered 5 as the last factor. That when you were dividing it gave you the 0 in the remainder, so you knew it stopped. The repeating decimal, however, does not stop at all. It repeats forever. So a repeating decimal is a decimal that continues with a digit or digits that repeat or repeats forever. Now, the reason why I put those funny little S's in there is because let's look at this example. 0 and 3 repeating, that means that only the 3 will repeat forever and ever and ever and ever and ever. Whereas if you look at this one, you have 0 and 900ths repeating, so that means 09090909090909. Okay, this one is 0 and 4500ths repeating, so it would be 4545454545. You will notice that there's a little bar written above the digit or the number that gets to repeat. This is called the repeating bar. The repeating bar is a symbol used to show that a digit repeats forever. And so wherever you see that bar covering, that's the number that repeats. So on this one, the example of 0 and 8, 3 repeating, only the 3 is going to repeat. So this number, if it was on a calculator, would look like 0 and 8, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, forever. Okay, because that's what identifies it as a repeating decimal. It won't ever stop. It's always going to have that 3 that trails. So the bar sits over only the digits that repeat. You need to know that for the repeating bar. Okay, so we have terminating decimals that stop. We have repeating decimals that repeat forever. Repeating bar is the symbol we use to show that. And so that's what we need to know about the two types of decimals. There's one other thing that you have to be able to do in order to be successful in this lesson. And that means that you have to be able to take any fraction and turn it into a decimal, no matter what the fraction is. And sometimes the fractions that you're given will not fit the pattern that I showed you before. For example, it says, if the denominator cannot be converted to a base 10 denominator, then treat the fraction as a division problem. And what I mean when I say that is read it as a division problem. So the example that I want you to do is -4 divided by 9. That's how you would turn that into a division problem instead of the fraction -4/9. You're going to say it -4 divided by 9. And what that means is -4 becomes your divisor, so it sits in the house or the vinculum. And the dividend, I apologize. -4 is the dividend, and then 9 is the divisor. So 9 is going into, or -4 is being split up into 9 groups of what number? Now, to go back to this, 9 does not have a multiple of base 10 ever. There is not a number that I can multiply by 9 that will give me a multiple of 10 in its denominator. 9 never will equal 10, 9 never will equal 100, 9 never will equal 1,000, and so on. And so this is one of those problems that you just have to do the long division and figure it out. So if you have -4 divided by 9, we can work on it together. So -4 is the dividend. I apologize for confusing those earlier. And 9 is the divisor. So the question is, how many times can 9 go into -4? And we're going to see if this is a terminating decimal or if it's a repeating decimal. So first thing we always need to know, a negative divided by a positive is always a negative. Can 9 go into 4? The answer is no. So we put a 0. Okay, subtract that out, and now we have 40. How many times can 9 go into 40? That's correct. The answer is 4 times, okay, which is 36. Uh-oh, look at what's happening, kiddos. How many times can 9 go into 40? 4 times, that's 36. And you should be able to see right now that there is something happening. So what do you think is happening now that we see the pattern that's going to take place all the way down the paper? If you said a repeater, you are correct. So the answer for this one is -0 and 4/10 repeating. That's how you read that answer. Okay? Again, the answer is -0 and 4/10 repeating. So that means that it's going to be 4, 4, 4, 4, 4, 4, 4, 4, 4 forever. So -0 and 4, 4, 4, 4, 4 forever. All right? So that is how we know how to take any fraction and turn it into a decimal. First, check it and see if it can have a multiple of base 10. If it cannot, you just treat it like a regular division problem, and then remembering your rules for dividing positive and negative numbers. Okay? I hope you guys understand everything that we're trying to share with this lesson. Let's quickly go back to our question of our lesson. And our question of our lesson was, what kind of equivalent fraction makes converting a fraction into a decimal the easiest? I will give you a huge hint. It has to have a what. It has to have a what. Because once you identify this, that makes it the easiest fraction to convert into a decimal. Okay? So the equivalent fraction that I'm looking for is one that has a right here. Okay? All right, kiddos, make sure that you get those questions answered in the notes today. You have 2 on the first page, you have 2 on the middle page, and you have none on the last page because we worked on them together. All right, my dears, have a good one. Bye.